When you're able to see my screen.
Yep, we can.
Okay, you are. All right. Okay, perfect. So we're going to talk about the CyberArk Privileged Access Security. But before we go into depth of what CyberArk does and how does it performs all the functionality, it is very important for us to understand what privileged accesses are, right? So does this term look familiar to any one of you? Privileged access, anyone? Privileged access. Does anyone care to define this term, privileged access? All right. If not, privileged access is basically any accounts within the environment, within the organizational architecture that has higher capabilities within the system, right? Let me give you an example. When you join a company, they'll give you a personal laptop, right? And sometimes you want to install certain things in that personal laptop. You will notice that it wouldn't allow you to do that installation, right? Software installation you want to do, it wouldn't allow you to do that installation. So you'll raise a request to the support desk and they'll remotely log into your laptop and install that software for you. How come they are able to do that installation, you are not? Because they are using a more powerful account to log into your laptop or to log into any server in order to do any kind of task, right? So any such account that has a higher capabilities, higher permissions within a system than a normal regular standard user, any such account that has more capabilities than a regular standard user will be identified as privileged account. And accesses that flows through these type of accounts are what we call privileged access, right? Anyone who uses these accounts to access the systems that contain sensitive information, this is what we call privileged access. Now, these accounts will have very high capabilities within the environment. They can be used to do any kind of modification, or they can be used to log into multiple servers with one single credential. This is why they become a risk at certain point of time, right? The first thing that attackers will always try to break is the password of your most important credential, most important account, which will grant them access to your important servers, right? So these type of accounts becomes risk at certain point, and they needs to be secured within a secure environment, and that's what CyberArk is going to provide, and that's what privileged access security is all about, right? Securing the privileged accounts within the organizational architecture. Privileged accounts are going to be created on every single device that you have, right? Windows system, Linux server, there's root account, databases, right? Printers, routers. For every single system, you'll have some privileged accounts, right? So let's understand more about these privileged accounts, understand the type of the privileged accounts that we are going to come across in the organizational architecture when we are working as a PAM engineers, the privileged access security engineers. What type of privileged accounts that we usually deal with, right? There are two types of privileged accounts that you're going to come across in our organizational architecture. First one being interactive privileged accounts. Interactive privileged accounts are usually the accounts that you interact with in frequent basis, right? They are also called human accounts because humans or individual users will use these type of accounts to personally or manually log into the systems. Right? If you want to log into a system, you'll write the username and password and hit the enter button to get inside the system. Right? So in some way you are interacting with the account. You're writing the username and password of the account. If any password change is required, you're going to do it yourself, right? Any modification on the account is required, right? Name modification or permission modification, you're going to do it yourself. Right. So in a way, you are frequently interacting with these accounts. These type of accounts that you regularly interact with are called interactive accounts or human accounts. Most common example of interactive accounts, super user account, right? Super user account are basically accounts that has the highest level of permission within the target system, within any system. You cannot have any account that has greater permission than this, right? So this account will have all the capabilities within the system. mostly these accounts will be created. The idea behind creating a super user account in any system is to be able to maintain that particular system. Right? For example, there is a Windows server that needs to be regularly maintained, patches needs to be applied, or policy needs to be modified, or upgrade needs to be done, or let's say user issue needs to be resolved, any new user needs to be created. So these kind of tasks will be done by a dedicated set of engineers who will be called infrastructure admins, Windows admins, right? They will regularly log into all the Windows servers within the organization and they'll perform these kind of maintenance work, right? So to do that, to do those kind of maintenance work that will require high capabilities within the system, they'll use the super user account, right? So for Linux system, you'll see root accounts. For databases, you'll see sysadmins. These type of accounts, the super user accounts, will regularly used by individual users of the server team or infrastructure team to perform regular maintenance work, right? Patchings and modifications. Similarly, we have another example of interactive account here, Active Directory Domain Administrator account. How many of you are familiar with Active Directory? Okay, do you know what Active Directory is? Yes. Can anyone define what Active Directory is? Active Directory is basically a virtual repository where all the resources within the organization will be stored. Resources as in um, servers within the company, how many servers do you have, or how many workstations, users laptop do you have, or how many user accounts or privileged account. The entry of every single resources created within the organizational environment will be stored in a virtual repository called Active Directory domain, right? Now, sometimes to be able to manage these vast number of resources, you'll need an administrator account, right? That will have the capability to log into all the resources one by one and do the maintenance work. So there will be dedicated set of Active Directory administrators who will use this Active Directory domain administrator account to log into the multiple systems and complete their work. Right? Similarly, we'll have local administrator or sysadmins for databases, local administrators for Windows. The idea here is that the interactive accounts are the accounts that are used by individual users, employees to manually log into the systems and perform their work. Right? But that's not true for non-human or non-interactive accounts. Non-interactive accounts are basically the accounts that are being used for uh, applications, right? Non-interactive accounts means there is no interactions with humans at all. During the login process or during the functionality, no interaction with humans at all. If you take an example of this hard-coded credential here, let's say we have a script that needs to be pushed to multiple systems in one single go, right? That there is a script, a Java code or a PowerShell code that needs to be pushed to multiple servers, hundreds of servers within very limited time frame, 5 minutes, right? So how do we do that? How does the script logs into multiple servers and performs those kind of functionality? Does it depend on humans? Because it's very difficult for humans to type in the username and password on hundreds of servers, right? In such a limited amount of time frame. So this is where the scripts, within the scripts, the organizations will write the username and password in plain text format, right? Username equals to this and password equals to this. They will write within the script itself, and the script will have the capability to read the username and password and automatically initiate a login to the different target systems in order to push its functionality. So during the entire process, the script will read the username and password, it logs into the server, push its functionality, and logs off. There is no interaction with humans at all. The script is doing everything by itself. There is no, I'm sorry, there's no interaction with humans at all, right? So these type of accounts there are where there are no interaction with humans, they are an example of non-interactive credentials. Okay, and since the username and password is written within the code itself, they are called hard-coded credentials. They are example of non-interactive accounts. Okay? Same goes for service account. You might have heard of service accounts, right? Very common term in the industry. Service accounts are basically accounts created within the services. And if you're not familiar of what services are, let me actually show you. Services are basically set of tasks that runs on periodic basis for any software that you install, and that software needs to do certain tasks automatically. Cannot depend on humans to do run those tasks on such frequent basis, right? So it's going to create a scheduled task, a service that will be responsible to run certain tasks on periodic basis automatically. Every 1 hour, every 2 hour, the service will run those tasks, right? Now, sometimes these softwares might need to extend their functionality to other systems as well. And this is where services will be responsible to log into other systems. But how does these services logs into other systems? How does anyone logs into any system? You'll have to provide username and password in order to log in, right? So this is where you can define the username and password within the service itself. You can define the username and password, and service can use this credential to automatically log into other systems and perform its work, right? So these type of credentials that you write within the service, they are called service accounts. Also an example of non-human or non-interactive accounts, because during the entire process, there is no interaction with humans at all, right? Everything is happening automatically. So that's the difference between interactive and non-interactive account. Now, when you implement a privileged access security solution, be it CyberArk or Thycotic or beyond, any other tool that you have in the market, when you implement a privileged access security solution, the first priority will always be the interactive privileged account, right? The first priority will always be the interactive privileged account. Why? Because these are the most sensitive accounts that you can have within the environment, right? Very powerful super user accounts or domain administrator account. And the most important reason is that the passwords, since these accounts are being used for interactive logins, manual logins, the passwords of these powerful accounts are directly exposed to individuals, right? Becomes very high risk when the passwords are directly exposed to users. The passwords can easily be stolen. And once the passwords are stolen, the entire environment is at risk, right? So the first priority will always be the interactive accounts. You need to make sure that the interactive accounts are secured. Non-interactive accounts are priority as well. They are important and sensitive as well, but not in case of interactive accounts. Our passwords are comparatively more exposed. This is why the priority number one is interactive account. For non-interactive accounts, CyberArk has another solution called Application Access Manager, and we'll talk about the non-interactive accounts as well, but the focus is going to be on the interactive privileged accounts, right? Okay, let's talk about why do we need a PAM solution in the first place? Why do we need privileged access security, right? What happens if we do not implement the privileged access security, and what can go wrong? Why customers, why clients these days are so aggressively looking to implement a privileged access security solution? Right, so let's talk about the risk that are associated with every single accounts that we have within the environment. We'll talk about these risks with certain live scenarios here, right? So let's take a situation. Uh, let's talk about this Active Directory domain administrator account, right? This account is created on a virtual repository on Active Directory domain, which contains the information of all the resources within the organization, right? If you're a large corporation, you're going to have thousands of servers within the environment, right? And this one single credential will have the ability to log into all 1,000 servers, right? One set of username and password can be used to log into all the servers, and not only log in, it will have the administrative capability to all the systems, right? It will have the administrator rights on all the servers. So if this type of credential gets compromised, the attacker can use them to log into any of the servers that they want with any of the rights that they want, right? So they will be able to do any kind of modifications or any kind of task that they want, right? And it's not like you have one or two domain administrator account within the environment, right? Every uh, organization that has the Active Directory domain are going to have multiple Active Directory engineers that will be working on multiple tasks, right? Someone will be working on policies, someone will be working on resource creation, right? Someone will be working on trouble user issues or troubleshooting, right? So everyone will have their own dedicated set of domain admin credential. So for a large corporation, 15 to 20 domain administrator accounts are a very, very common practice, right? Any one of these accounts gets compromised, your entire environment is at risk. So you cannot leave these such sensitive credentials or such powerful credentials unsecured, right? They are very, very high risk. So they needs to be protected in a best way that with the organization's capability, right? Second, there should be a centralized repository for all privileged accounts. Helps in auditing, right? If you know what auditing means, auditors are basically individuals who are responsible to track the processes within the environment and make sure that the processes are being followed as per the standards defined by regulatory bodies. And if there are any deviations from the processes, they need to report those kind of deviation, right? So if even within the privileged access environment, the organization, the auditors will have the responsibility to track the privileged accounts activities, right? But the problem here is that privileged accounts will be created on multiple layers within the environment, right? In a architecture, privileged accounts will be created on multiple layers. Some privileged accounts will be created on Windows servers, something will be there with the Linux servers, right? Sometimes the situation will be so complicated that even within one single server, you'll have multiple privileged accounts being managed at multiple places, right? To understand the scenario, let's take an example. Let's say we have a application team, let's say a database team that wants to build another instance of their database, right? That wants to build another instance of their database. So how do they install this database? They'll need a server for that. Let's say they need a Linux server to build the database. They'll ask for the Linux server team to create a Linux server for them. So they raise the request, the Linux server team creates the request, and as soon as they create the server, the Linux server, they'll create a root account within the Linux server, the built-in root account that they'll use, the Linux team will use to uh, do the regular patchings and the policies and user creations, all that stuffs that Linux team is responsible to do. And once they have the root account, they'll hand over the server to the database team. Now, once the database team gets the server, they'll install their instance of the database where they'll create their own database administrator account, which they'll use to manage the entire database, right? So now in one single server, we have two privileged accounts. One, the root account, which is being managed by the Linux server team, and second, the database account, which is being managed by the database administrator. So within one single server, we have two privileged accounts, which is being managed at two different places, right? And if this is the process that organizations follow, this is going to be the case with all the 1,000 servers that you have, right? Privileged accounts created on every single server will be managed at multiple places. Becomes very, very tough, very complicated for auditors to audit these kind of privileged accounts, right? If they want to audit the activities of the Linux server, they'll have to go to root, they'll have to go to the Linux team to retrieve the activities. If they want to audit the activities of the database administrator account, they'll have to go to database team to retrieve those activities, right? The process becomes very, very complicated for them. And to protect these type of, to mitigate these type of scenarios, this is where CyberArk can be helpful, or any privileged access security solution can be helpful, right? They can offer a centralized platform where all privileged accounts can be onboarded, irrespective of the platforms that they are created on, irrespective of the operating systems that they are created on. All privileged accounts can be ordered in one single repository. And anyone who wants to use these sensitive accounts, they'll first have to authenticate themselves in CyberArk, validate their ID, and only once they are properly authenticated, they will be allowed to use the account. But in this process, CyberArk is going to generate a detailed trail for every single account activity, saying that this user has used this account at this point of time, and these are the activities that the user has performed. Right? So auditors will have access to everything in this case. All they need to do is simply log into the UI, and every single detail will be waiting for them in a more friendly user interface. Right? The logs of every single account, the activities, who has used the account to log into what server, what point of time, what are the activities that they have performed, what are the permissions that they had, right? So every single activities can be tracked on one single repository. When CyberArk is in place, auditors will be, uh, it will be very simplified process for auditors, and there are very less chances of auditors missing out on important details, right? So centralized repository helps in auditing. Third, accountability should be there. Detailed accountability. If let's say you do not have CyberArk in place or any privileged access security solution in place, how do you usually connect to the servers, right? You simply initiate this remote desktop connection client. I hope you guys know what this remote desktop connection client is. This is a software that allows you to connect to multiple servers remotely from your personal laptop. But as long as you know the username and password of the account, you would be able to connect to the server, right? So let's say I know the IP address of a server, I know the username and password of the account. Let's say very sensitive account, a domain administrator account. So I'll just type in the username and password. I'll get connected to the server this way, right? And once I'm logged into the server, I'll choose to perform certain unauthorized activity, any activity that I was not supposed to perform, right? So if I do that kind of activity, there will not be any tracks there, right? Because I'm masking my identity here. I'm using an administrator account. Instead of using Sanjeev ID and password, I'm using an administrator account to log into the server and perform the work, right? And server logs in this case, they are going to say that the activity was performed by administrator, right? Nobody knows that Sanjeev has used the administrator account to connect to the server and perform the activity, since the server logs are only going to say that the activity was performed by administrator. So there is no track. No one knows which accounts are being used by which individuals and what kind of tasks are being performed. There is no trails here, right? No accountability at all. Anyone can get away with anything that they do, even when they are using the most powerful credentials, right? Anyone can get away with anything that they do. So this is where, in order to protect these type of credentials, CyberArk can be helpful here as well. It can onboard this administrator credential into the CyberArk repository, and it can rotate the passwords of the privileged accounts, right? It can change the password. So as soon as the account is onboarded to CyberArk environment, changes the password, and Sanjeev no longer has the access to the password now. So direct connections cannot be made now, as the password is not exposed. I do not know the password. I no longer have access to the server directly from my personal machine. So if I'm a genuine user and I want to use the account, I'm authorized to use the account to connect to the system, I should be logging into the CyberArk portal where I can authenticate myself. And once I'm properly authenticated, I'll be able to see the account and initiate a connection to the server that I want using that account onboarded in CyberArk. But CyberArk will initiate the connection on behalf of me. It enters the username and password on the backend. It gets me connected to the server so that I can perform my task, but it still does not discloses the password to me. So the major benefit here, users will be able to connect to the servers using the powerful account. They will be able to do their task. They will be able to perform their work, but the password will not be exposed to the users, right? Without getting the password exposed, CyberArk would be able to connect the users to the target servers And once the users are connected to the target server, their sessions will be monitored. Monitored as in detailed trails will be generated what kind of activities that they are performing. CyberArk is going to generate a detailed trail that Sanjeev has used the administrator account to connect to this server at this point of time. And once connected, Sanjeev has initiated this application, navigated to this local drive, right open control panel, all the activities that I did. There will be a detailed trail generated in a text format tracking my activities. And along with that, my entire session will be recorded in video format, right? So even a cursor move is going to be visible for the auditors to see. The entire session will be recorded in video format when I use a sensitive credential, a powerful credential, right? So this is how CyberArk will provide much more control and much more visibility to the auditors when sensitive credentials are being used. And this is how it's going to ensure accountability within the environment. If users are using powerful credentials, they are accountable for their actions. They know that they are being monitored and they are being recorded, so they are accountable for their actions. Right? Apart from this, CyberArk also helps you to gain compliance standards placed by some regulatory bodies. So if you guys have worked in the industry for some insurance or banking domains, you might have heard of SOX compliance or payment card interface compliance, right? If you have worked for a healthcare domain, there is HIPAA compliance. All these regulatory bodies have certain standards in place which every organization working in the industry are supposed to follow. And if you fail to follow these standards, you get the privileged accounts compromised or the environment compromised. There can be a lot of repercussion, right? So you might lose your data that you have, or you might lose your existing client. You damage your reputation, right? Your lawsuits will be involved. Fines will be imposed by these regulatory bodies. So not an ideal situation to be in, right? So this is why companies these days are aggressively looking to implement the privileged access security solutions like CyberArk, right? This is why this domain is growing domain day by day. Let's quickly cover the requirement from the privileged access security solution. If you are investing so much money into a PAM solution, a privileged access management or privileged access security solution, what are some standard expectations from that investment, right? How do you think that the CyberArk solution is going to provide a secure environment for your privileged accounts, and how does it adds value to your infrastructure, right? So let's understand certain features that CyberArk can provide that can be helpful in order to protect your privileged accounts, right? The first thing, the ability to manage the privileged accounts or the ability to rotate the passwords of the privileged account. Ideally, you should not keep static passwords for a longer period of time, right? Static passwords are never a good idea, right? Because they are bound to get exposed at certain point of time. So you should be able to rotate the passwords on frequent basis. Right? Every 30 days or every 60 days, the passwords of the privileged account should automatically be rotated. But the problem here is that if you're a large corporation, you are going to have at least 1,000 servers, and within each server, there will be at least one or two privileged accounts. Manually changing the passwords of these privileged accounts every 30 days or every 60 days can be a burden on your support desk, right? You might not have enough resources to handle this kind of workload, right? So this is where solutions in CyberArk, you would be able to define policies, right? Policies related to the rotation of the passwords. How frequently the passwords of these privileged accounts should be rotated, right? So every 30 days or every 60 days, these passwords can be rotated. And you can even define the complexity of the passwords, right? Do they include any special character, or do they include any digits? All these complexity can be defined, and CyberArk would be able to read these policies, the rotation period, and the complexity, and it will automatically execute the password changes for you based on the time period that you define. Second, the ability to limit the access to the privileged account. Not everyone should be allowed to access these privileged account. Only the individuals that has the ability to use the privileged account should only the individuals that has the requirement to use the privileged account, those individuals should have access, right? Least privilege method should be imposed, as in only those permission needs to be provided that individuals require in order to complete their task, right? Let's take an example of a developer who needs to log into a server where they need to perform certain code changes and then they need to log off. That's all. Right. So simple modification on a notepad file or a script. They do not need to do any policy modification or they do not need to install any software on the server. So do they need access to the administrator account? No, right? You can simply create a less privileged account for them and grant them the access that way. Read only account and grant them access that way. So this is what CyberArk will help you to achieve, limiting the access to the privileged accounts. Not everyone should have it, only the individuals that really require these permissions to complete their task. We talked about the audit trails, detailed logs of which user using what account to connect to what systems at what point of time, with what activities that they are doing, right, along with the video recording of the entire session. So whenever sensitive credentials are being used, the audit trails will be generated in very detail. Keystroke logins, as in any high privileged command that you execute in a command line interface, such as, let's say if you're logged into a Linux server and you run commands like password reset or add user, these type of commands will be recorded in text format and will be available for the auditors to see. So detailed audit trails will be generated for whenever sensitive accounts are being used in CyberArk environment. It will be generating the detailed audit trails. Multi-factor authentication, as in any user that wants to log into the CyberArk portal will have to validate their identity twice, right? Dual factor authentication. So you might have heard of this term, right? Multi-factor authentication, very common term in even our daily to daily life. If you deal with online transactions, banking transaction, you might have seen this, right? When you log into your banking portal, you write username and password, and it asks for OTP, one-time password, and only when you provide the OTP, it allows you to log in. So it's validating your identity twice. There are multiple factors of authentication, and this can avoid user impersonation, right? Nobody can steal your credential and get access to the resources that you have. So CyberArk will allow, it does not have its own MFA functionality at this moment, but CyberArk allows you to integrate with all the MFA solutions that are out there in the market, right? So you can integrate it with Okta, Radius, RSA tokens, right? Google Authenticator, OTPs, everything is going to work. Detailed session management, as in monitoring of the sessions, every single sessions that are being initiated using the CyberArk account secured within CyberArk. There will be a detailed track monitoring will be done with trails generated, video recordings, and session isolation will be there. Now, this is a very important features that I would like to highlight. Usually, when you do not have the CyberArk solution in place, what you usually do is you initiate the remote desktop connection client. You write the IP address, username, and password, and you get yourself connected to the servers. Right? But in this case, sometimes it can be risky because you might have some bad scripts or some malware in your personal laptop that can easily be pushed into the servers that contain sensitive information. Right? So to protect this from happening, to protect the direct interaction between the user laptop and the target server, CyberArk is going to place a jump server in between. Right now, this jump server is basically a server that sits in between the user laptop and the target server. So every single time a user initiates a connection from their personal laptop to the target server, it's going to go through the CyberArk server. Connection will be initiated to the CyberArk server first, and from the CyberArk server, the connection to the target server will be initiated, right? So it's going to isolate the user laptop and the target server. That's what we call session isolation. right? And the last feature we have here is temporary access. If the user does not need accesses on permanent basis, they should not be granted access on the permanent basis, right? So in the tool, the CyberArk tool, you would be able to request for access on a temporary basis, define the time period for which you need the access, and CyberArk can read that time period and deprovision the accesses as soon as the period expires. Right, so temporary accesses can be provisioned as well in the CyberArk environment. These are some standard expectation, standard features that you need to look out for while implementing the privileged access security solution. Right. I don't think we have enough time today. Otherwise, we would have talked about the CyberArk's approach to manage the privileged accounts within the environment. Right. So, in probably the next sessions that whenever we are going to have it, we will have a detailed diagrams and explanations on the CyberArk environment with some graphical diagrams. I'll try to explain the components that CyberArk has and the type of functionality that it has and how does it manages all these expectations that you have from a privileged access security solution, or how does it mitigates the risk that we have, right? That's something we are going to discuss in more detail in the coming session, probably the first session whenever we have it. Um, Let me give you a quick overview on the syllabus and your expectations from this course. So this is how the syllabus looks like. Right? In module 1, we are going to talk about the introduction of the privileged access management. So the pain areas, what the problems, what are the challenges, and what are the associated risks associated risks with every single privileged accounts that you create within the environment, right? And how to provide a solution with the help of privileged access security tool, right? Module 2, we are going to try and talk about the different architecture of CyberArk systems, and we'll talk about the approach that CyberArk follows to mitigate the risk and manage all the expectation. Module 3, we are going to talk about the theory of every single component that we have. We'll talk about the theory of CyberArk Vault. And so basically, CyberArk is not a component that can be installed on one single server and it performs all the functionality. It has to be installed on multiple servers. Multiple components are there for different functionality. For the storage, the repository, we have the vault. For front-end user access, we have the password vault web access, right? For session management and logs and trails, we have the privileged session manager. For automatic rotation of passwords, we have central policy manager, right? For accessing the vault in a client format, we have the client. So in module 3, we are going to try and spend 1 hour to half an hour on each of these components. We'll try to learn the prerequisite. We'll try to learn the functionality of the component and the communication part, right? And any accounts, service accounts that are running on the backend processes that gets executed in order to achieve all the functionality that this components performs, right? Module 5, we once we have discussed all the theory, once you're comfortable with the theory of all these components, we are going to provision your accesses to the virtual lab environment where we will build 5 virtual machines hosted in the AWS cloud. For every single one of you, dedicatedly, the 5 virtual machines will be created. You'll have your own credential that you can use to log into the AWS environment. The softwares will be copied in these virtual machines, and we will be responsible to build the entire CyberArk solution from scratch. So we will learn the prerequisite in terms of network requirement and hardware requirement, right? And we'll start the installation of every single CyberArk component. So basically, we'll build the entire environment from scratch in the AWS cloud. Right, so Vault installation will build our own Active Directory, will build our own email notification engine, which triggers alerts if anything goes wrong within the environment, right? All the CyberArk components will install one by one. And once the architecture installation is finished, so we'll talk about the detailed steps of the installation during the session itself. But along with the session, every session will be recorded and you'll have the access to the recordings later on. So you can take a reference and follow the same set of procedures in your lab, local lab as well. And along with that, we'll also provide this exercise guide to you, which contains the detailed installation steps along with screenshot. So every single step is detailed here along with the detailed screenshot that you can follow and do the similar set of exercises in your local lab environment so that you get a complete hands-on, right? You get a hands-on to build the product from scratch and you get a hands-on to complete the exercise guides as well, right? So once the installation is complete, we are going to talk about the policies, right? So in the installation, once the installation is complete, the architecture will be there, but it's going to be completely blank. So we are going to talk about the policies. How do we set policies in CyberArk in order to govern the security of the privileged account? In Module 8, we are going to talk about the access management. How do we allow our users to have access to the privileged accounts that we secure within CyberArk environment? So different type of access metrics, right? Safe level access or object level access. In module 9, we are going to try and onboard different sets of accounts within CyberArk, Windows account or Linux account or database account, right? Um, Module 10 will be all about the use cases. So daily to daily tasks that we do in CyberArk. As a CyberArk administrator, when you join an environment, in a running environment, what kind of task you will be responsible to do, right? So basic onboarding task or manual onboarding, right? Password reconciliation, right? Uh, Auditing reporting will have a dedicated session for reporting where we will talk about the uh, reports that we can retrieve and help our auditors in a way that they can do their auditing properly, right? Session recording and deletion of the accounts from CyberArk. Module 11 is now integrated with the 13 itself. In module 12, we are going to talk about the detailed troubleshooting steps. So if you are working as a CyberArk administrator, sometimes things will go wrong for you, right? Sometimes you notice that suddenly users are not able to log in and there are certain challenges, right? So you will be responsible to fix these kind of issues. So in module 12, we are going to talk about the detailed troubleshooting steps and how do you approach different type of user issues or different type of password management issues? What kind of log files do you check, and what is your approach? What's your approach looks like, right? Module 13 is going to be the last module where we will talk about the disaster recovery, which is basically a replica of the primary architecture, which gets activated only when the primary architecture is not responding. So in module 13, we are going to set up a fault tolerance from scratch. We'll build DR servers and we'll make sure that our users do not face interruption, even when the primary servers are not working. Right. So apart from the installation lab guide, you'll also have this administration exercise, which will contain a lot of operations use cases, daily to daily use cases. If you want to work as a CyberArk administrator, the user management task and the password management task. Right. We'll talk about these topics in sessions as well, but you'll have some more exercises here to practice. This is for dedicatedly for your practice. So this contains 240 page of booklet only for exercises. So you can go through these exercises and work on your lab environment, right? Complete these exercises. So completely for self-study. Uh, Install lab guide for all the installation and integration. And apart from that, we have a handwritten notes which contains the theory of every single environment within the every single topic, every single component within the CyberArk environment. So along with the vault, the PVWA and the PSM and the CPM. And this is something that I have tried to highlight the important topics that are very important from certification perspective or interview perspective. So you can go through this theory notes as well to understand the important topics, and most of the interview questions are going to come from here, right? So very, very important from theory, from certification and interview perspective. Apart from all this, we'll also help you with we'll set up a dedicated session for certification to maximize them, and interview preparation. We are going to have a dedicated session for the certification and interview preparation. Once our regular duration is completed, once our regular session is complete, the duration of the training is going to be 20 hours. Okay? Uh, Study materials, you'll have permanent access to them. Virtual labs, AWS labs, since they are built on cloud, the labs are going to be available for 35 days from the day of start. Um, Training duration is 20 hours. We are covering certification, interview, right? What else? I think that's it. With this, I'll probably leave the session for any open questions that you guys might have. So please go ahead. You can unmute yourself
Hey,
and
hi,
ask the questions directly.
hi, Sanjeev. Thanks, actually. Sanjeev Gaurav this side. So I would
Yes.
be more like interested in the HA kind of a setup. So CyberArk like core pass, I'm working since 6 years. So not an actual project, but did a couple of basically my internal projects or POC kind of environment I have built. So I'm more
Okay.
interested in like looking at or setting up the
That's it.
HA and DR. Yeah, so because this product is a quite complex and it fits in like a complex hybrid kind of environments.
Right.
So most of the customer basically when we deal with, so they have like a different kind of a data center distributed across different geographies. So how can we
Right.
deploy that and understanding the core concept of quorum disk? So that is the main part which I would be more
Okay.
interested in. Yeah.
Okay. Sure. So what we are going to do for you, Gaurav, we are going to talk about the HA cluster architecture. We are going to talk about the standalone, and we are going to talk about the distributed or satellite architecture. Right.
Okay.
I can give you detailed diagrams, detailed explanation, and explain every single steps. I can give you detailed process of implementing those kind of architecture. But on the lab environment, the AWS environment will only be working with a standalone. But I'll give you directions on how to implement the cluster architecture.
Yeah. So main thing is Sanjeev, I have the own infrastructure. Even like I have the VMware license, VMware setup as well. So I can configure like servers, but I need some assistance to set up kind of HA environment. So
Right.
that is one of the which I would be looking forward.
Yes, Gaurav. So probably something that you'll have to talk to me separately about this. During the training, the course will only cover the standalone architecture. I can give you detailed diagrams on the HA cluster, distributed satellite. That is something I can cover in the sessions as well, with detailed diagrams and explanation explaining every single stuff how these architecture works. But on the lab environment, we'll go with the standalone certification. There are uh, used to be 4 levels. Now they have reduced it to 3 levels of certification. Level 1 is trustee. Trustee is now discontinued, so we'll not talk about that. Level 2 is defender. Defender is basically the test of administration slash operations knowledge, daily to daily task that you are able to perform within the environment. Uh, right? Multiple choice questions with 30, sorry, 65 multiple choice questions with 2 hours of time. Cost is 200 USD, right? Valid permanently. And the last level is Sentry certification, which is basically the test of your deployment capability, installation of the tools from scratch. Same goes for Sentry as well, multiple choice questions with 2 hours of time and 200 USD per attempt, right? We are going to cover all these 3 levels of certifications, Defender and Sentry, both the administration operation topics and deployment and installation. From the topic wise, we'll prepare you for these certification. And if you are covering the exercise guides and use cases and going through our sessions carefully, you would be able to clear both of these certifications. They are not that hard, right? But you have to appear separately for this. Schedule these exams from CyberArk website, pay the cost, and appear for the exam. Only when you clear this, you get the certification.